All right, hello. We are going to work this problem right here. This is, I guess this is homework 2, 2021, the third semester. So that would be the fall semester if we include the summer. Anyway, so we're going to work this problem, and I'm just going to kind of walk you through how I would solve this. So we could call this the key. Hopefully I won't make a mistake and discover that this is not the key. This is, just some non-key. So I'm also going to go through like how to arrange, what I expect to see on your page when I do this. Okay, so we've got, so we're going to go over here, and let's see, so you have copies of the questions. So, basically we're just going to, so what I'll do is, so what I expect really is up at the top, if you were on your engineering paper, you'd have this top little area up here. And let's see, so you would write something like homework 2, and this would be, you don't have to write the description. Sometimes I like to do it anyway, adding vectors. And then we would add the class, and this is statics, or you could say ENCE 2350. And then you would write your student ID number. Let's just say it's student ID number, so let's say it's 1, 2, 3, 4, 5, 6, 7. And this is going to be the page number. So we're going to start with page 1, because I don't know how many pages this is going to be. In this case, it's going to be 1. So this will be the first page out of however many pages it is. My guess is, of course, this is going to end up being 1 page because, I'm on an I thing, right? So I just have one giant page. Anyway, so what we'd do is we'd say given. I'm going to write down what we were given. We're given that A equals 24 newtons. Okay, at an angle of 217 degrees. Let me zoom in a little bit so you guys can see what I'm doing. And we'll do B equals 17 newtons at an angle of 102 degrees. These are annoying angles, right? Because they're greater than 90. But, such is life, Okay, so now what's required? Okay, well, we want the resultant equals what? Using the triangle method. Okay, so that's just going to be a bunch of trig, right? The triangle method. And then we're going to get the resultant equals what? Using the components. Okay, and that's kind of like A and B. I guess we could label that. This would be A, this would be B. And B kind of has a side part, which is, convert this to polar coordinates to check your answer. Okay, so basically what we're going to do is we're going to solve this 2 different ways, and then we're just going to make sure that they say the same thing. Okay, so let's go to the solution. Okay, and most of this, this is one of the reasons why we always do things on graph papers, because it makes our lives a lot easier. Okay, so I'm going to create, give myself a little space here. This is also one of the advantages of kind of, looking at the problem ahead of time and knowing what's coming, is I know that both of these vectors kind of go off to the left. So I'm going to give myself some space here. Knowing that we're going off to the left. All right, so let's see here. Vector A, 217 degrees. So let's see, if we start here, we're going to go 90, another 90, so that's 180. And now we need to go 37 degrees. Now, I don't have a protractor, so this is totally just going to be a guess. Right, so I'm going to go like this. Let's see, I want 24 newtons. So what if I went 24, 48, say we went 9.6 centimeters in this direction. 9.6 centimeters. Okay, boom. Okay, so that's 24 newtons. Okay, now again, like I'm totally guessing on whether or not I've got the, whether or not I've got the angle right. But I'm kind of giving this a rough guess. This is 37 degrees, right? Because it was, 217, so we want the 180, and that was what was left over. And now what I like to do with these is I'm going to go over here to this spot, and I'm going to create more dotted lines. Because I know I'm doing the triangle method, and the dotted lines help me figure out where I know that there's 90 and where I don't know anything, right? So, so we'll kind of draw this little dotted lines going like this. Okay, so I'll do tip to tail with B. So B is 17 at 102. Okay, so we go 90 and then we're gonna go an additional 12. So that's gonna be pretty tight because that's a pretty small thing. And we're going 17, so we'll go 17 times 4 is what? 3468. So we'll go 6.8 centimeters up at a pretty tight angle. So we'll go like from here up to here, a pretty tight angle. Again, totally, you know, maybe not totally guessed, but you know, this 17-degree angle is pretty small and pretty hard to draw. Let me zoom in so that I can make that angle, you know, prettier. You know, this is really ugly. All right, so we can write a nice 17 degrees right there. And we can write a 17, wait, was it 17 newtons? That's not 17, it's 12 degrees, excuse me. This is 12 degrees. Okay, so let's go ahead and erase that. Let's make this 12 degrees. Okay, come on, you can do it. Okay, 12 degrees. All right, so now that's what we got, okay? So we want to get the resultant here. And maybe I'll give the resultant a different color. Maybe I'll give it blue. It'll match its background. Right, and let's see, so. So there's the resultant. That's what we're looking for. All right. So what I want is I want that, the size of that vector, and I want that angle right there. So I'm going to guess based on my drawing, and of course my drawing is not perfect, but I'm going to guess based on my drawing that maybe, okay, let's see how many centimeters this is. It looks like it's about 13. So if we divide 130 by 4, what's that, 65? So, 113 by 4. Is that right? Is that how I was doing these? Oh, right, I zoomed in and out, right? So that's a problem. All right, so my scale no longer holds. Anyway, it looks like this one might be a little longer than the 24. Let's see, if I use my my ruler at this length, it's 12 inches. Oh, that's actually quite nice. Or 12 centimeters, excuse me. And at this one, I'm getting about 13. It looks like 12 and a half. So I'm guessing, if I had to guess the length of this line, I'm going to guess. You don't have to guess, but I like to kind of have a guess. I'm going to guess that this is about 25 newtons at an angle of, looks like it's a little less than 37. So let's just go ahead and say like 20 degrees. Okay, that's my guess. Okay. If I get something way off of that, then something's really wrong. My drawing is wrong, or you know, any number of other things could be going wrong here. All right, so as I mark this thing up, I'm going to mark it up in red so that hopefully you guys can follow my logic. Okay, so we're going to do this triangle, and what we're looking for is this resultant vector right here. Actually, I'm going to just label that as R without the vector symbol on top, because I want the length of this line, and I want this angle right down there, which I don't really know what to call that blue angle. Anyway, so let's see, but right now I don't have any interior angles. I have parts of interior angles, but I don't have anything else. So what I'm going to do is I'm going to note that this right here is 37 degrees, okay, because alternate interior angle of this 37, right, because those dotted lines are parallel. And then I'll note that that means that I know this angle right here, because it's the rest of the way to 90, right? So that means that this one right here is 53 degrees. Okay, so that tells me an angle, right? Now I know something that I want to work with. I'll do it in green. So I know from here to here is 53 plus 12. So that's 65 degrees. 65 degrees. That green is really ugly to look at, isn't it? We probably won't use that again. What else do I know? Well, that actually seems like it's enough, actually, right? Because now I know a side, I know an angle, and I know a side. Okay, so once you have a side, angle, side in an order, you can get the side opposite. So we can get R. Okay, so I'm going to go to black, and I'll do the work for that. So I'll say, so from the law of cosines, let's see, I want to make sure that I'm, let's see, R squared equals A squared plus B squared minus 2AB cosine of the angle between them. Okay, so r squared equals a squared, which is 24 newtons squared, plus 17 newtons squared, minus 2 times 24 newtons times 17 newtons, okay, cosine of 65 degrees. Okay, so if we solve that all the way, I'm going to get r equals 22.807 newtons. Okay, cool. All right, got it. Okay, obviously we're going to want to report that with 3 sig figs, but let's keep them all the way down. Okay, so then what I want to do is I want to see, now that I know that equals 22.807 newtons. So now I've got all 3 sides. I've got one interior angle, which is this 65 over here, right? 65 degrees. So from that, I can do law of sines to get anything, right? Once you have the 3 sides and one angle, you can get all the other sides with using law of sines. So again, we have to work with sides that are opposite each other. So this one and the 65 are across from each other. Okay, so we'll do, let's see here. So I'll do sine of gamma over r equals, and I just need a picture, which angle do I want? Well, the angle that I want in this case is this angle right here, because I'm trying to figure out the angle for that resultant, right? So we'll go ahead and do that. We'll call that one, let's see, 17 is B. So we'll call this the sine of beta. Okay, so we're going to go ahead and work on that. So let's see here, sine of gamma, so that's the sine of 65 degrees over r, which is 22.807, oh, not degrees, newtons, pardon me, equals the sine of beta, that's what we're looking for, is beta, okay, divided by b. Well, b is 17 newtons. Okay, and then if we solve for this all the way, beta equals, let's see, 5 significant figures. This is a place where that's really unnecessary, but whatever. We're going to stay with the format. Okay, so that tells us this red angle is 42.497. This red angle is 42.497 degrees. So that means the angle that we're looking for, this blue angle right here, is 42.497 minus 37. So that's 5.497, I guess, 497 degrees. Okay, so basically the answer that we would report is I would take these two together, and when we get to the reporting stage, we're going to do it with 3 sig figs. So R equals 22.8 newtons at an angle of 5.50 degrees. Okay, and that's my answer. If we compare that to my guess up here, 25 at 20 degrees, not too bad. Okay, I mean, not perfect, but, we do the best we can. So what we're going to do now is we're going to, okay, so that's part A. I guess I should have called that A up here. And then we're going to go down here. Actually, let's go ahead and let's do another page. Okay, so let's imagine we've just got another page down here. Come on, you can zoom in, buddy. All right, let's see here. Where's my trusty dusty ruler? And what we would do if we had a second page is we would go down here and we would say, okay, let's kind of more or less try to keep it aligned. Obviously, you're going to have pages that are actually aligned, right? And we would spend 8 seconds or whatever it costs to rewrite this heading. Okay, we'd write, okay, statics. Okay, student ID number. 1, 2, 3, 4, 5, 6, 7. And this is page 2 out of, well, who knows how many pages we're going to get, right? Okay, so what we're going to do now is we're going to use the component method, okay? So there's a few different ways you can do it with components, or a few different ways you can draw it. I guess you don't even necessarily have to draw it. I'm going to draw it just because I prefer that. So here we go. If this were a slicker video, I would have it just kind of like, pop up, I'd pause it and draw it while it's paused, but I don't think I want to do that. I think I'm going to do it this way right now. Okay, let's see here. Uh-oh. I just endurance hunted my dog. Did me about 5 minutes of running in a circle. But he got tired. All right, so let's see. So we've got this force going off this way. Right there, and that's 24 newtons. And it's got an angle of, what is this, 37 degrees, right? Okay. And, a lot of times people will draw these forces just all coming out of the origin. I'm not going to do that right now because I don't feel like it. I'm going to make this other force. I'm going to kind of do it almost like tip to tail. I'm basically going to recreate the drawing from over there on the left. Over there above on page 1 or whatever. Just because I like it, right? So now we're going to go up this way. This is going to be a 12 degrees off of that vertical. Okay, and that's kind of hard to draw, right? So we'll zoom way in, if it will let me, of course. And I'll draw this little 12 degrees right here, 12 degrees, okay? Kind of hard to draw, but this is 17 newtons. All right, so this time what we're going to do is we're going to do the components, okay? And so I'll do the components over here, and I'll say A equals, and then I'm going to work a little bit sideways here, but let's go ahead and, so I'm going to draw A, and I'll do A in blue, because it's going to look like this, right? So here we go. We got A going to here. That's AX. And then we got AY going this way. Okay, and this is AY. Okay, if this is X and Y, right? Okay, so AX, from the trig, so let's see. I'll go ahead and kind of do the trig up here. I'll do, let's see, okay, so we've got, let's just start with sine. Sine of 37 degrees equals, come on, you don't need to jump around like that, punk. Come on, okay. Opposite, AY over the hypotenuse, which is 24, okay? So AY equals 24 newtons times the sine of 37 degrees. Okay, AX, well, usually if one's sine, the other's going to be the cosine, right? 37 degrees equals the adjacent side to that angle, which is AX, divided by 24 newtons. So AX equals 24 newtons cosine 37. Okay, I'm going to go ahead and figure out, just plug those in the calculator real quick and find what those numbers are. Okay, and so we'll take those numbers and we'll put them in over here for A. So we'll have 19.167 in the I, and that's actually a negative, isn't it? Because it's going off to the left. And the AY is also negative because it's going down, and we'll do 14.444 newtons, not newtons. I mean, it is newtons, but let's try to be a little bit more consistent, shall we? So we'll put a 4 right here, and we'll put a J right there. Okay, and we'll go like this, and then we'll put a newtons right there. Okay, so there you go. Now we'll do B. Okay, so let's see. We're going to go down here and look at B. And again, I guess I'll do the trig above it. I guess I could do this in, let's do red. Okay, so B looks like this. Start at this point. Here's my Y component. As best I can draw a vertical line, which is not that good apparently. And here is the X component. Notice the X component is negative, the Y component is positive. All right, so I've got that 12 degrees. So let's, again, we're going to go sine of 12 degrees equals, so the opposite, which is going to be AX, equals AX over the hypotenuse, which is 17 newtons. So AX equals 17 newtons sine of 12 degrees. Okay, and then we'll do the cosine of 12 degrees. So that's the adjacent side over here. So that's AY. equals AY over the hypotenuse, which is 17 newtons. Okay, so AY equals 17 newtons cosine of 12 degrees. Okay, so again, you know, we're going to plug those into the numbers. You don't need to listen while I do that. All right, so we get these, you know, fancy numbers, and we'll go over here to B, and we'll just copy those numbers in. We'll note that this is negative in the X and positive in the Y, so we'll go over here. I'm going to use black again. So let's see, we end up with negative 3.5345 in the I, and a plus 16.629 in the J. Okay, and we're going to go ahead and put newtons around the outside of that and draw a line. And we're just going to add them up, and here's our resultant. Okay, the I's go to the I's, and I'm going to get negative 22.702 in the I. And this is going to be a positive 2.185 in the J. Okay, and that's going to have units of newtons. Okay, now if we note, okay, so that's now part B, right? That's our answer for, well, I guess that's not the answer we want to report because, right, because it's got too many sig figs. But note, the way that I like to think about this when I'm like, well, what are we doing when we're doing all this stuff, right? So what we're doing is, if I think about it in the X direction, is I move, what, 19.167 in this direction. And then I move another 3.5345 in that direction, okay? In the vertical, right, so that's this number and this number. In the vertical, I'm going to go down this number and then back up that number. So I go down 14.444 to get down to here. And then I'm going to turn around and I'm going to go back up 16.629 to go back up this way, right? So that's what ultimately creates, you know, my full traveling distance, okay? So anyway, so let's go stare back here at our number. And for the number that we're going to report, we'll go ahead and round this to 3. So I'll say R equals negative 22.7 in the I plus 2.19 in the J. And that has units of newtons. Don't ever forget your units, right? Okay? And so that's the B part, I guess, of this assignment. And we'll go back up to our requireds. So we did it using the triangle methods, we did it using components, and now we want to convert to polar coordinates to check our answers. So let's go over here, and we will convert this answer to polar coordinates, okay? So, noting that when we do this, we want to make sure that we use the 5 sig figs, right? So we'll say, okay, so R, the magnitude of this thing, equals the square root of 22.702 newtons squared plus 2.185 newtons squared. Okay, so R equals, if we plug that into the calculator, we get 22.807 newtons. Okay. And then we were going to get the theta. Okay, and so we want to go back over here. And we want to look at the resultant triangle, right? So the resultant triangle looks like this. Let's see here. This is the resultant triangle. Like this. Okay, or something along those lines. Okay, and this is Rx, this is R, and this is Ry. And so we just found R using the Pythagorean theorem. But now I want to get this angle theta. Okay. And we get that by doing so we take note of the fact that the tangent of that angle is the opposite over the adjacent. Okay, so we'll go down here, and I'm going to go ahead and erase this because I jumped ahead of myself a little bit. So we'll say the tangent of that angle is the opposite, which is Ry, which is this number, over Rx. Okay, the opposite over the adjacent. So we'll go ahead and plug those numbers in. Tan theta equals the opposite, 2.185 newtons, divided by the adjacent, which is 22.702 newtons. Okay, noting that these two things, the units will always cancel out because you can't take the inverse tangent of something that has units. So, or the inverse, really, anything So those will cancel out. So we'll get theta equals the inverse tangent of 2.185 over 22.702. Okay, and if we plug that in, we're going to get theta equals 5.4976 degrees. Okay, a very nice number. Okay, so if we combine these to report, okay, I can say, well, let's zoom in over here. I can say, well, R equals 22.8 newtons at an angle, okay, north of west of 5.50 degrees. Okay, and if I've done this correctly, right, we need adverbs, that number should match this one. Okay, and it does. Okay, so, and that's, you know, on an exam, I would expect you to make sure your numbers match. Okay, we'll go back down here, and this is now the second page out of 2. This is the first page out of 2. And that is, right there, is how you would get a, 100% on this particular assignment. So hopefully that helps you guys. And, again, take care of yourselves. Know that I'm here for you. And let's, be easy and all that other stuff. Bye. Noting